Hello everyone. Now we are looking at the third topic in AI introduction unit. This is AI models. So, for building an AI solution for a problem, we need to build a model. To build a model, we need to have data knowledge mapping. How is it done? So, here first is we have a discover phase, then a model phase. One is discover relationship, second is mapping, third is knowledge based model building, fourth is a application building. So let's look at it quickly. Discover relationship. This is the research phase where AI is used to find hidden patterns that the humans might miss. What is the goal of this? To understand why and how the data points operate. There are techniques where clustering, correlation analysis, unsupervised learning. These are techniques used. So, what is a use case example is analyzing sales data of a let's assume or a store, big store. So a customer buys product A almost always. Second is product B on Tuesdays. A relationship you did not know existed. As a owner of the shop, we may not know why this person is buying such a trend. So these kind of patterns are analyzed by AI. Second is mapping. Mapping is organizing information and creating a directory on how different data points connect to each other. See, 2 points are there, and how they are connected is something the AI model will generate. So, to create a visual or a digital map of the data landscape, whatever data we are giving, it will create a digital map. See, the techniques are data labeling, vector embeddings, and semantic search. So, assume a factory is cataloging company files, thousands of company files. And if we search for safety protocols, automatically it will pull up helmet requirements because AI understands they are related. Third is knowledge based model. This quadrant is taking the existing unstructured human knowledge and turning it to a structured AI model. This is the actual model building. So, the goal is to capture how things work so that AI can replicate. Okay, so creating knowledge graph. The techniques are creating knowledge graph, fine tuning models where there will be hiccups or small issues, and those will be fine tuned during modeling. Okay, third is example, building a diagnostic tool for a specialized field like medical tool, so which are very specialized and it will follow specific logical rules. This is the third. Fourth is actually the application building. This is the most common action quadrant. It involves taking an AI model and wrapping into a functional tool for users. See, the goal is to deliver a finished product. Okay. Techniques are API integration, agentic workflows. I'll talk about agentic workflows in other videos. Okay. What is the use case? A customer support chatbot. Like Amazon, if you are trying to contact the customer service, they are using AI for this. Now let's look at the types of models that are there. One is semiotic model or symbolic AI. The semiotic model is based on the idea that intelligence can be achieved by manipulating symbols. Let's look at an example. See, it uses if then statements. See, if it is raining, symbol A, you go outside, symbol B, then you will get wet, symbol C. Okay, this is logic driven. The transparency, these are called white boxes. Because the rules are written by humans, you can exactly trace why the A made a specific decision. Because of the transparency, we'll know why the A made a decision. Same as example is medical diagnostic equipments we have seen, right? So those are, we know how it will work. Okay. Second is statistical model. Statistical models often referred to as machine learning or neural networks. They do not follow hard coded rules. Instead, they use mathematical functions to find patterns and correlations within massive data sets. If it sees photos of 10,000 photos of cats, it learns statistical probability that a certain pixel can represent a cat. It actually doesn't know what a cat is, but out of 10,000 photos, the data set learns that this kind of patterns exist in this type, which is cat. It actually doesn't know what a cat is. Okay, it calculates on 98% probability. The input we are asking is for a cat. Okay, examples are LLM, large language model, or image generator. If we ask for a cat, it will generate based on the photos it has on cats. Understood? Hope you understood. If they have any questions, please ask in the comments. All the best, students. Thank you for watching.